from chemical kinetics. Chemical kinetics. So chemical kinetics is a chapter of first year FEC, first year chemistry. Clear? So it is a very important chapter with respect to all types of tests, including gate tests or commission tests, including KPPSC, पंजाब पब्लिक सर्विस कमीशन, फेडरल पब्लिक सर्विस कमीशन एक्सेट्रा, और साथ साथ जो प्री मेडिकल वाले तैयारी कर रहे होते हैं, क्लियर, इंक्लूडिंग एमडीकेट वगैरह, उनके पॉइंट ऑफ व्यू से इंतहाई ही इम्पोर्टेंट होने वाली है। और मैं तमाम जो चीज़ें, मतलब ये है कि ये सेकंड लेक्चर है, वैसे जो चीज़ें रेट ऑफ रिएक्शन को इफ़ेक्ट करती हैं वो यहाँ पर देख सकते हैं इंशाल्लाह। मैं फर्स्ट ऑफ ऑल जस्ट लाइक इंट्रोडक्टरी आप लोगों के साथ शेयर करता हूँ, फिर स्टेप वाइज जितनी भी मतलब MCQs आने के चांसेस इससे होते हैं इंशाल्लाह मैं आप लोगों के साथ शेयर करूँगा। क्लियर? सो देयर आर सम फैक्टर which affect the rate of reaction. So you should know what is rate of reaction. So rate of reaction is a change in concentration of reactants or change in concentration of product in unit time. Clear? So what is rate? Rate is actually the change in concentration of reactants or products in unit time. Unit time means in hour, 1 hour, in second, in minute, in year, in month, in day. Clear? These are all unit time. Clear? So first of all we discuss about concentration. So we discuss that how concentration can affect the rate of reaction. Clear? You know, as for example, if A react with B and form C, these are reactants and these are products. Clear? So there are some MCQs to which I want to share with you. Initially the rate of reaction is very high. These all contents I have talked in first lecture. A react with B and form C, which is a product. Clear? So you know the reaction occur, this product is formed when they collide with each other. If collision does not occur, rate of reaction, no reaction will occur. Clear? If A and B collide with each other, then product will formed. If A and B does not come in contact, does not collide with each other, then the product C will not formed. Clear? So it means if we increase the concentration of A and B, the rate or the chance of collision will increases. The chance of collision will increases, and as a result the formation of product will also increases. It means as we increase the concentration, the rate of reaction is also increases. So all reactions have no same trend of increasing the rate. Clear? So there are many types of reaction in which sometimes the rate of effect decreases with increasing concentration. There are some reactions in which the rate of reaction does not change with increasing the concentration. Clear? So there are some reactions in which when we increase the concentration of one reactant, the rate of reaction does not change, and there are other some type of reactions in which when we increase the concentration of one type of reactants, the rate of reaction is increases. So I want to explain these all with suitable examples. Clear? So first of all I want to discuss a type of reaction which does not depend upon the rate of the concentration of the reactants. So that is one photochemical reaction. Photochemical reaction. Clear? So photochemical reaction photochemical reaction does not depends upon the concentration of the reactants. For example, that is alkane which react with Cl2 in the presence of photon, clear, and form CCl4 plus HCl, clear. These are type of photochemical reaction. So you know the photochemical reaction start when the radiation from the sun break up the Cl-Cl bond, clear, the Cl-Cl bond. It does not start only by the collision of alkane with chlorine, clear. So this type of reaction started when ultraviolet radiation breaks the chlorine-chlorine bond. As a result, when chlorine-chlorine bond break, the chlorine radical is formed, which are very reactive, and chemical reaction initiate and propagate and terminate, clear. So photochemical reaction the rate of photochemical reaction doesn't depend upon the concentration, clear. So the next case, there are some type of reaction when we increase the concentration of one reactant, the rate of reaction does not affect, clear. So for example, generally suppose NH3, clear, is added to water and form what? Ammonium hydroxide, and form what? Suppose this is a type of reaction, clear. This is a type of reaction where ammonia react with water and form ammonium hydroxide. Neutralization reaction takes place. So if the water is so much, clear, if it is in excess, clear, देखें, if we have taken lot of water is in excess, so much water is present here, clear. You know only one molecule of H2 is responsible, is enough to react with NH3, but we have taken a lot of water. For example, the ratio, if we take the ratio of NH3 and H2O in a beaker is such that in this beaker the H2O molecule and NH3 are present in such ratio, NH3 and H2, clear. If the ratio is 1 to 100, it means that, suppose for understanding, for one NH3 molecule there are 100 molecule of H2O. It means a large number of H2O is present to react with NH3. So the actually one molecule of H2O will react with NH3, clear. It means if we take here 100 molecules or moles of H2O are available to react with 1 mole or 1 molecule of NH3, clear. So if we increase more water, clear, 100 is present and we add more, clear, a 10 mole or 10 water molecule are added further, the rate of reaction does not affect, clear, because the only one molecule is enough for one NH3, clear. So the addition of further H2O molecule does not affect the rate of reaction, because the rate of reaction also depends upon this molecule, the increasing the concentration of this molecule. So if it does not increase the concentration of NH3, the rate of reaction will not affect, clear. So these are type of reaction when we increase the concentration of one type of reactant, the rate of reaction does not affect, clear. So आगे चलते हैं, इसकी मिसाल मैं कुछ यूँ दे सकता हूँ, क्लियर, इसकी मिसाल अगर आप लोगों को समझ नहीं आ रही तो इसकी मिसाल मैं कुछ यूँ दे सकता हूँ. This is a forest. Clear? This is a forest. In this forest, there are approximately thousands of trees. Thousands of trees. Clear? And there is a man who have only one ox. Only one ox. And this man can cut one tree in 30 minutes. 30 minutes. So this is a very long time that this man can cut only one tree in 30 minutes. Clear? So what happened? So if we decrease some amount of some trees from this forest, the efficiency of this man cannot increase or increase or decrease. Clear? Because there are a lot of trees in this forest. Clear? So his efficiency, his rate, his power does not affect, because there are lot of trees in this forest and this man is not able to cut these all at a time. Clear? So the rate doesn't affect, the rate will propagate with same rate, because this man cut the trees with same rate, 30 minutes per tree. Clear? So the next case, if we increase the number of ox. Clear? If we increase the number of ox. Clear? So when we increase the number of ox, then in 30 minutes 1 2 3 4 4 tree will cut down. In if the number of ox become 5, then the number of trees in 30 minutes will be 5, and so on. It means this is an ox, and these are trees. Clear? This is an ox and these are trees. So if we does not increase the number of ox and the number of trees are in excess, so increasing the trees does not affect the rate of reaction, because the one ox can cut one tree in 30 minutes. Clear? So on the other hand, if we increase the concentration of ox, the rate of reaction increases, because as we increase the number of ox, the rate of cutting of trees is also increases. Clear? It means rate of reaction increases. Clear? So we have discussed three type of reactions, photochemical reactions, which does not depend upon the concentration of the reactants. Second one, these are type of reaction in which the rate of reaction does not affect when we increase the concentration of only one type of reactant. Clear? If we increase or decrease the concentration of only one type of reactants. Another type, there are some type of reactions when we increase the concentration of one type of reactants, the rate of reaction increases. Clear? It means this example of, if we increase the concentration of NH3, the rate of reaction is also increases. So these all about concentration, but there are some other type of reactions that when we increases the concentration, the rate of reaction also increases. For example, photosynthesis reaction, CO2 react with H2O and form C6 देखें and form C6H12O6. Clear? This is a type of this is a type of reaction in which carbon dioxide react with water to form glucose. Clear? So as the concentration of these reactants increases, the product is also increases. Clear? So this type of reaction, the rate of such type of reaction increases as we increase the concentration of reactants. So In such case, the rate of reaction depends upon on the concentration of both. So you have understood that some type of reactions doesn't depend upon the concentration. Some type of reaction depends upon the rate of some type of reaction depends upon on only the concentration of the one reactants. Clear? And there are some type of reactions in which the rate of reaction depend upon on both the concentration of the both reactants. Clear? So आगे चलते हैं. आगे क्या है? आगे है हमारा टेम्परेचर. So you know there are so many reactions. Basically there are two type of reaction. Write down these in your own notebook. Clear? If you listen this lecture and watch this lecture as a story, that it has no benefits. Clear? You should write down these all in your own notebook. Clear? And repeat them. So temperature, there are basically two types of reactions. Two types: endothermic and exothermic. Clear? Endothermic and exothermic. One type of is, there are basically two types of reactions. Endothermic. Endothermic. Endo means inside. Inside. Thermic means heat. Clear? Endothermic. And the other one is exothermic. Exothermic. Clear? So the endothermic reaction are the type of reactions when we heat them. These are type of reactions when we increase the heat, when increase the temperature of such type of reactions, the rate of reaction increases. The rate of reaction increases because the number of collision increases. Clear? The bond length increases. Clear? The energy for transition state increases. Clear? So the energy for the activation energy become available. So these are type of reactions. When we increase the temperature for such type of reactions, the rate of reaction increases. But there are some type of other reactions, when we increase the temperature, their activity decreases. Clear? Though they become inert. Clear? Because they are exothermic. They want to elevate their temperature. So in such type of reactions, the reactant do not want to absorb energy. They want to lose energy, but when we give them energy, they don't absorb the heat, and also they lose the ability to react with each other. Clear? So such type of reactions are known as exothermic reactions, and their rate decreases with increasing temperature. Clear? So हम आगे चलते हैं. वैसे there is a lot detail in this chapter, so we cannot explain about how temperature affect the rate of reactions. The temperature have wide detail in this chapter, so inshallah we will discuss it in detail. Basically there are so many ways and so many theories which explain how the rate of reaction affected by temperature. Clear? So in some theories and in some laws, we can say that in our textbooks it is given as that if the rise in temperature is 10 degrees Celsius, if we rise the temperature for some reactions by 10 degrees Celsius, their rate will increase by 2 times or 3 times, which are known as temperature coefficient. So inshallah we will discuss later with detail. Clear? So the next case is nature of reactants. You know, there are 3 types or 4 types of the metals. Number 1, type of metals which have covalent bond in their molecule, in their structure as a whole. Clear? So other type, there are some type of molecules, compounds, formula units which have ionic bond in their structure. Clear? Other type of matter which have metallic bond, not a covalent bond, or ionic bond in their structure. Clear? So some have, some have van der Waals force. All molecule have van der Waals force in between these their molecules. Clear? So the temperature or reactants, nature of the reactants, it means according to an famous statement that like dissolve like dissolve like, it means that polar molecule will dissolve polar molecule, polar molecule will dissolve polar molecule, non-polar molecule dissolve non-polar molecule, ionic molecule cannot dissolve ionic molecule if they are in solid phase. Clear? So most of the ionic compounds are in solid phase. Clear? So polar can dissolve polar, non-polar can dissolve non-polar, polar can dissolve polar, non-polar can dissolve non-polar. Clear? Also ionic can be dissolved in polar, but ionic cannot dissolve ionic because most of the ionic compounds are in solid phase. They are compact and not in mobile phase, so we should dissolve them in polar solvent. Clear? So you know, if we dissolve polar in polar, the rate of reaction will be high. Clear? For example, if we take uh, alcohol, if we take alcohol and dissolve it in water. Clear? In water, they will, the alcohol will dissolve in water very fastly. Clear? So it is, for example, suppose this is polar and this is also polar, so the rate of reaction of alcohol with water is very high, is very high. Clear? So polar or dissolve can be dissolved in polar very fast. It means the reaction between polar and polar are very high. So in such, they can dissolve here. This I am taking as an example. Clear? No chemical reaction takes place, they are in the combination by covalent bond. Clear? Sorry, they are in a combination of van der Waals forces and hydrogen bond. When we dissolve alcohol in water, they form hydrogen bond with each other. No chemical reaction takes place. Then, for example, I am explaining this example in order to understand you. Clear? These all terms will be explained later with the suitable examples. Clear? So, nature of reactant is very important for the rate. If the reactants are of a same nature, if the reactants are of same nature, the rate of reaction will be increases. If we clear, these compound are polar and this is also have polar nature, so they can react with each other. Clear? For example, if we dissolve carboxylic acid, or for example, if we dissolve alkyl halide, if we dissolve alkyl halide in water, this is an alkyl halide in water, so in water it can form carboxylic acid. Why this react with water? Because acyl halide, clear, acyl halide react with water because they have same polar nature. This is a functional group, this is a functional group which can react with water, and this carbon will act as an electrophile. Clear? And water molecule will act as a nucleophile. So inshallah we will discuss it in detail. So they can undergo chemical reaction because they are in same nature. There is some affinity for the reaction, but because this is a polar and this is also a polar, but when we add C6H6 in this water, there will be no reaction, there will be no reaction, because they have different affinities for the reaction, they have different nature. Clear? So you should know the nature is also important for the chemical reaction. If two reactants have different nature, different bonds, clear, different attractive force inside the molecule, their reaction will be different. Clear? If we take AgCl and want to dissolve in water, it will be dissolved in water. And if we take this HCl and want to dissolve it in benzene, it will not dissolve, because benzene and HCl have different natures. Ionic compounds can be dissolved in polar, but that is non-polar, so HCl cannot be dissolved in benzene, because benzene is a non-polar. Clear? I hope that you are understood. For example, another type of example, देखें, we have taken silver nitrate and react with sodium chloride, so it is an ionic reaction. So what will happen? AgCl will precipitate in water, plus sodium nitrate are in association. Clear? They are both in association in the aqueous solution. If we take an aqueous solution of sodium chloride, or sometime for MCQs, the aqueous solution of sodium chloride is known as brine. So if we add silver nitrate, clear, so what will happen? The AgCl will precipitate, and sodium will be in association with nitrate. Clear? It will be in soluble form in the aqueous solution. It means here, if you concentrate here, if you give attention on here, sodium nitrate react with sodium chloride with very fast speed. Clear? So the rate of reaction for such type of reaction is very high, but these reactant does not, sodium chloride or even sodium nitrate does not react with this benzene, because they have different nature. You should understand that ionic substance can react with polar substance, ionic cannot react with non-polar substance. Clear? So again, so the other one क्या है? फर्स्ट फेज ऑफ रिएक्टेंट्स. क्लियर? फेज ऑफ रिएक्टेंट्स. अब फेज से यहाँ पर हमारा क्या मतलब है? फेज देखें, मैटर आर बेसिकली इन थ्री स्टेट्स. क्लियर? वन इज गैस, अदर इज लिक्विड, क्लियर, and third one is solid. So the rate of reaction for a gas is higher than liquid, which is higher than solid. In most cases, it is not for all cases. Clear? So in most cases, the rate of reaction for gases is higher than liquid, and it is higher than solids, because the rate of reaction depends upon the number of collision per time. So the number of collision in a gas molecule is higher than liquid. So if collision increases, the rate of reaction is also increases. Clear? So the rate of reaction for gas is in most cases higher than liquid, which is higher than solid. Clear? So the main fact for this is coming below, that is surface area. Clear? I am explaining this reason by surface area. Clear? So gas react fast than liquid, which react fast than solid. Why? Because gaseous molecule are separated from each other. If they separate from each other, their surface area will be increases. Clear? If the surface area increases, the rate of collision increases. Clear? The contacts of A and B also increases. For example, this is a matter, this is a matter. Clear? And their particles are randomly arranged here. Clear? Clear? So this is a solid, this is a solid, and suppose these are all A type. Clear? This is a matter which all are in what form? In a form of A. It is elements or atoms of A. Clear? This is another matter which is a type of B and having particle B. Clear? So if they are in such form that they are separated from each other, clear, so they can react with each other very fastly. They, clear, they are, if they are separated from each other, if we write B in such form and A also write A in such form, it means they are gases. The gas molecule are separated from each other, so they can collide with each other. They can collide with each other randomly and form, and as a result chemical reaction takes place. Clear? So the other type, liquid. In liquid you can see they are in molten form. Clear? It is not necessary that the all molecule of A can react with B, because the upper molecule of liquid can react with the upper molecule of B, but the lower molecule cannot come in contact of A with B or B with A. Clear? So those molecules which can come in contact with A or of molecule of B which come in contact with A can react with each other, but those molecules of A or B which are beneath the other molecules cannot react as fast as the upper molecule. So it means the rate of collision, rate of coming in contact, clear, of the liquid is less than of gas. It means the rate of collision of liquid is less than of a gas. It means the rate of reaction depends upon the number of collision. It means the gas molecule react fast as liquid, and you should know that in a gas, in a solid phase, this reaction are not fast possible. If both terms are in, if both are in solid phase, the solid phase reactants cannot react with each other. That's why if I take sodium silver nitrate and sodium chloride, they cannot react with each other because these both are in solid phase. If I want to react to react Ag with Cl, clear, then first of all I will form the aqueous solution of both, and then I will mix them. Then after mixing they will come in contact and take a collision, clear, and as a result chemical reaction will take place. So the next case is intensity. I hope that you will be understood phase and surface area. The other term that I want to share with you is that there are two types of phases. Phases means states. For example, when a type of reaction takes place, suppose A react with B, if A and B are in homogeneous state, if this is a gas and this is a gas, if A is in liquid and B is in a liquid state, clear, if both are homogeneous, if A react with B, both are gases, or if A and B are liquid and the reaction will be high, the rate of reaction will be high if they are homogeneous, in a state, clear. If both the reactants are gases, the rate of reaction will be high. If both the reactants are liquid, both of the rate of reaction will be high. If the one reactant is in solid and the other is in a gas phase, or one is a gas or the other is liquid, clear, the rate of reaction will be low, clear. So going ahead, note down these all factors. Clear? For homogeneous species, the rate of reaction is greater than the heterogeneous one. Clear? If both reactants are all in same state, gases or liquids, the rate of reaction will be higher than if they are in solid, liquid or heterogeneous phase. So the next one is intensity. Next one is intensity. Intensity means increase in photon numbers per unit area. Clear? If the number of photon increases, the rate of reaction increases, because most of radical will be formed. There are some type of reactions which only depends upon the intensity of light. Some type of reactions which only depends upon the intensity of light, does not depends upon the concentration of the reactants. Clear? So if I take Cl2 plus H2. Clear? When they come in contact in the presence of H mu. Clear? So if one photon is present, then it will form only two radical. If two photon is present, then it will form four radical. If three photon, then six radical. It means that as the intensity increases, photon increases. As the intensity increases, number of photon increases. If number of photon increases, rate of reaction increases. Clear? So next case, catalyst. Catalyst can also alter the rate of reaction. Clear? For example, if A react with B and form C. Clear? So there is a barrier from which the reactants will pass to form a product C. What is this barrier? This barrier is just like a hill. Clear? If the B and C want to cross this hill, or if the A and B want to form this product, these A and B will cross this hill. Clear? The peak of this hill. Clear? So what is the role of catalyst? Catalyst work is so first of all, I draw it as that this is the energy. If A react with B and form C. Clear? So what will happen? We will give energy to A and B, so much of energy. This energy should be equal to activation energy. Clear? So what is activation energy? Activation energy is the minimum amount of energy which can carry the reactant up to transition state. What is activation energy? Activation energy is the minimum amount of energy which is required to carry these reactants up to transition state. Clear? Another definition: activation energy is an amount of energy which is necessary to start a chemical reaction. Clear concept? If A and B want to form a product C, then it is necessary that A and B will cross this barrier. Clear? So if they want to cross this barrier, they will absorb energy. So from what source they will absorb this energy? From the external source, these A and B will absorb this energy. So here this is a type of reaction without a catalyst. Clear? So if we use a catalyst, so what will happen? Catalyst form another way and decrease the activation energy, or decrease the peak of hill. Clear? The peak of hill. So if there is no catalyst, we will give the amount of energy up to that point. But if we use a catalyst, we will give energy to A and B up to that point. Clear? It means the catalyst decreases the activation energy. If the activation energy decreases, the chance of formation of product increases. So if the chance of formation of product increases, at that time the decrease in the change in the concentration of the reactant also increases. It means rate of reaction increases, change in concentration of reactants and product increases. It means rate of reaction increases. So catalyst can increase the rate of reaction because catalyst catalyst decrease the activation energy. And what is activation energy? Activation energy just like a barrier from which reactant will pass. Clear? Okay. So it is the this point or this point is also known as transition state. Clear? Transition state. So if we use a catalyst, least amount of energy will be required to convert reactants into products. Clear? Because the transition, if we use a catalyst, the transition state come very fast. Clear? By applying small amount of energy. So the other one is reactivity. So the rate of reaction also depends upon the reactivity of the reactants. Reactivity of the reactant. For example, we have HCOO negative and R. If I take it as clear, it will be very conceptual. Then it will be very conceptual for you people. Again, in both cases, which one will be reactive of them? Clear? We know that this is a base and this is also a base, but the reactivity of a base depends upon the strength of the base. If the strength of the base is high, their reactivity will be high. So now you know that here the R group induct or motivate its electron density toward this point, this carbon. If their electron density come here, the electron density also increases here. Clear? You can write these two example as clear as and as clear. This oxygen is acting as a base. So here the ability of alkyl group to induct, to motivate its electron density toward this carbon is greater than this hydrogen. So it means the negative charge will be higher here as compared to that point. Again, the property of the alkyl group to induct its electron density toward this carbon is higher than hydrogen. It means if the charge density of the electron here is higher than this point, it means the charge density of negative on oxygen here is greater than this one. It means if the charge density increases, reactivity increases, it means this one is most reactive than this one. Clear? So reactivity also increases the rate of reaction. Clear? Again, another example. For example, if we have taken Cl negative and CH3 COO negative. Clear? You know that this is a conjugate base of acetic acid and this is a conjugate base of HCl. HCl is a strong base. HCl is a strong base. Stronger the base, weaker will be conjugate, stronger the acid. Sorry, this is a conjugate base of acetic acid and this is a conjugate base of HCl. HCl is a strong acid. Stronger the acid, weaker will be its conjugate base. It means Cl is weak conjugate base, so its acidity, so its reactivity is less than acetate ion. Clear? It means acetate ion is reactive than chloride ion, so the reactivity of the acetate ion is greater than chloride ion. The reactivity of acetate ion is greater than chloride ion, it means if the reactivity increases, the rate of reaction increases. Another way, you should note down these all, that what I am saying to you. If the solubility increases, stability decreases. If, for example, that this is an acetic acid, if the solubility increases, solubility if solubility increases, stability decreases. If solubility increases, stability decreases. Clear? If stability decreases, reactivity increases, rate of reaction increases. Clear? So note down these all tricks and tips. So the next one is solvent. So you should know solvent can affect the rate of reaction. Clear? As you know that in the society where you live, clear, can motivate and discourage for some actions. Solvent work is, clear, as this is your society and you are living here. Clear? If you want to do this one difficult task, then the other people can motivate or can discourage you. Clear? So these people can affect your goal. Clear? Sometime they they discourage you and you lost all of your courage. Clear? So solvent work is, sometime the solvent increases the reactivity of the solvent increases the reactivity of the reactants, and sometimes the solvent decreases the reactivity of the reactants. So inshallah we will discuss about this all in detail in the next lecture. So you should subscribe my channel and click on all notification bell icon in order to get the updated notification of such a beneficial lectures. Clear? So I want best of luck for you people. So you should I hope that you should be understood, and you should also like this all lecture. So I hope that you will come in my next lecture, and there is all first my first and second lecture is also present on this lecture or on this channel, which is about the chemical kinetics. So you should watch the previous video, which is also beneficial for you people. So good luck.